Hi everyone, my name is Bobby Gregg at the University of Michigan. I'm very sorry that you're not able to join us in person during these challenging times. And so that means you'll get to miss the wonderful campus that we have here, as well as the beautiful new robotics building. But we're doing our best to give you a good impression of what life would be like as a graduate student at Michigan Robotics. And so my role in this is one as the next graduate chair for robotics, as well as the instructor for Robotics 501, which is the Mathematics for Robotics course. So the purpose of Rob 501 is to get all of us on the same page about the fundamental mathematics that we will need in the various robotics courses you will take here, as well as your research as a graduate student. And that's most important because of the fact that robotics is truly an interdisciplinary program. People come from mechanical engineering, electrical engineering, biomedical engineering, aerospace engineering, naval engineering, computer science, and so on and so on. And so we all come from different backgrounds. Some of us have seen plenty of linear algebra, some of us haven't. Some of us have seen plenty of probability theory, some of us haven't. But the beauty of this course is that by the time you're done with it, we'll all have the necessary fundamentals, either new concepts that you haven't learned before, or going deeper and reinforcing concepts that you have seen before. So as a brief overview, we start off Rob 501 going over proof techniques. So how do you prove mathematical theorems? So we spend a couple lectures on that. Then we move on to abstract linear algebra and matrix properties and so on, vector spaces, that type of thing. Then we'll move on to least squares problems, something called the normal equations. You've probably heard of least squares before. It's used for regression. And we talk about general least squares problem formulations and solutions. We also will go into filtering, which will also involve a review of probability theory, random variables, and probability distributions, which will then lead into common filtering. So that's a really important tool for robotics applications. It's a pretty ubiquitous sensing method to fuse information between sensors. And so we also will go over introductory real analysis, which is really important for understanding how to prove convergence of sequences or signals, which is super important for control theory, as well as optimization theory, convergence of optimization, algorithms, and so on. We also will cover convexity. So what is a convex set? What is a convex function? As well as optimization from linear programs to quadratic programs, which again are also very useful in robotics applications. So in terms of prerequisites, we hope that you will know basic matrix algebra, such as multiplying and inverting matrices, matrix rank, determinant, that kind of thing. And if you haven't seen this in some time, that's okay, because there's plenty of resources online for this. That hopefully you have seen probability before, but it is not uncommon for people to have never taken a probability course, never have seen a random variable. And so we do provide handouts to help get prepared for that as well. Vector calculus is really important in this class, so you would want to review that, as well as simple properties of complex numbers. So how do you add and multiply complex numbers? And use of MATLAB. So we do rely on MATLAB quite a bit in this class. And so again, you might want to brush up on MATLAB. But other than that, the whole goal of this class is to get different perspectives, different backgrounds in the same room, and make sure that we're all experts in these fundamental mathematical concepts by the time you are done taking Rob 501 at the end of your fall semester. So I look forward to seeing you at Michigan, and feel free to reach out if you have any questions about Rob 501 or the graduate program in general. All right, bye-bye.